In this video, we're going to show you how to build a DIY solar-powered weather station, and we're going to do it with ESPHome and bring all your local weather data straight into Home Assistant to drive all your automations. Let's check it out. Now you may be asking, well, why do I need this? I can just use some other third-party service such as Dark Sky or National Weather Service, etc. to bring all that data straight into Home Assistant. Well, I kind of thought the same thing, but until I built this device and wanted to grab my own sensor data straight from my backyard, it has really turned out to be a great project. One really cool thing that I have plans for is the Lux sensor on mine. Instead of using just a time-based latitude, longitude, type of sensor to shut off my outdoor lighting based on what season it is, well, I want to drive that actually by what the current weather is, because if it's just a cloudy day and it's been raining all day, sometimes I want the lights to turn on a little earlier. Well, I can do that now with this Lux sensor. So we're going to go ahead and build this system with ESPHome, and it does have a little bit of soldering, but the soldering is very simple. It's all through hole soldering, so don't run off just yet. It's a pretty cool project that we're going to build, and the boards, you can buy them actually from PCBWay. And the whole project could be parted out, whether you can grab things from Amazon, AliExpress, or whatever your favorite website for grabbing various sensors and pieces for electronics. And you may have some of them just laying around already. Or you can grab the whole kit and caboodle straight from PCBWay if you want to go that route instead of trying to piece things out. Now the boards, of course, you will get from PCBWay. I will leave all the links down in the description below. So you can see the board is fairly simple. It's laid out with some space. It makes it super simple to solder. So don't be scared. If you haven't soldered yet, this might be a good project to get started on and get your feet wet on soldering. So let's get to it and build this thing. So the boards at the heart of the solar weather station are made by PCB, and they're really great high quality boards. As you can see here, they are very simple to solder straight on the back, and everything is labeled and drilled perfectly for you to put all your devices and solder on. So we're going to turn this board into this. It may look like a lot to do on the board, but it's very simple, and we'll get the soldering done and put the various devices on it step by step. Now we'll leave a link down below. It is for the kit all-in-one from PCBWay. That way you don't have to chase down any parts and go to various websites and wait for it and maybe miss some pieces that have possibly changed. You can get it all from PCBWay, all in one box. Now of course you will have to provide your own lithium-ion battery, and you will have to provide your own case. But other than that, you get everything all in one box, and it's a very simple project to solder and get started with doing your own weather station. Now sure, if you do want to go ahead and piece it out and build it all yourself without doing the kit and just order the PCB boards from PCBWay, sure, by all means you can go that route as well. First, what you'll want to do is take the board and all the pieces that come in the kit, or if you did piece them out separately, go ahead and make sure you have all the pieces and kind of do like a little test fit first. So some of the stuff that comes with the D1 Mini, we won't need these longer pins. Put those to the side. Now the battery charging module, on my build, I'm not going to put the sockets on it because typically I'm not going to be changing that out, say like I would a sensor or a Wemos D1 Mini. What I'm going to do is just simply put 2 male header pins on each side and then a single on here and solder it straight to the board and solder the top of this. So what will make it easier is solder your shortest components first, and then we'll come back and do these header pins that are all raised, and we'll do them at one time. That way we can just set the board down. Then we got our charging module, BME 280, and D1 Mini Pro all soldered up, ready to go for the socketing. Now let's get to the board. And one thing that will make it easier once you do the D1 Mini is to go ahead and plug the D1 Mini into it. You know you'll get them straight up and down. That'll be easy to plug in. And then you solder it like this. Of course, to make it even easier, we'll use the third hand to finish it up. Find one thing that helps. If you have an extra arm on your third hand, you can use that to prop your hand up instead of floating in the air. Helps out a good bit. Also, another thing that helps out a good bit is not recording this while you're at a weird angle. You're trying to do it on camera. So for batteries to power the solar Wi-Fi weather station, I chose this pack that I could get readily available off of Amazon in the US. Of course, you can use just about any type of lithium ion cell as long as it is the 18650, and you do want to use a high capacity one, of course. This one also doubled as a USB power pack that could feed other USB devices if needed. Thought that was a kind of a cool little feature, plus it did charge both cells. And you could change the amperage to charge each of them, and it just uses a standard USB cable to charge the batteries. And of course, since this does not come with the PCBWay kit, we'll definitely leave a link to the product down below. If you're not familiar with ESPHome, we did a video several months ago doing your own little DIY multi-sensor for use in the home. So if you do want to go watch that video and build that project, or just scan through it and check it out, I would highly recommend it. It kind of builds out the basics of how to get started with ESPHome. So we're not going to show the install of ESPHome. It's a very easy add-on you can do in HASS.io, or for the Docker folks that run things in their own containers, you can also just install the Docker container manually. We'll leave all the links on how to get started down with ESPHome. That'll get the documentation for you to get installed and going. So let's go ahead and jump into the ESPHome dashboard and get this unit programmed. So what you'll need to do is go into your ESPHome dashboard, and we'll make a new node. This is going to be an easy placeholder because we will provide the entire YAML file for you to copy and paste. We'll call the node Solar Weather, and we'll go ahead and pick the Wemos D1 Mini. We don't really need to pick the Wemos D1 Mini Pro. I did have one little minor issue of trying to send OTA updates with that one, but I just chose the Wemos D1 Mini. We don't need the extra amount of flash RAM that one provides anyway. We're only using that one because it does allow the external Wi-Fi antenna. Continue, and we'll put in whatever we want for the SSID, and same thing for password, since we will be copying and pasting into our file from the secrets, which you probably should be using your secrets YAML file, right? If you aren't, it definitely makes it easy to just put your Wi-Fi SSID and password in one spot, and then you can share all your YAML files with other people without accidentally sharing your Wi-Fi SSID and password, especially on live streams. I don't know who does that. Hit continue, and we'll hit submit. At this point, don't go pick your upload port and all that just yet. No matter if you're doing a direct connect or if you're just going to send it over through the ESPHome flasher, we need to copy in all these sensor settings. So go ahead and find your solar weather, and you'll click edit. Now, if you'd like, you can just drop in the YAML file that we're going to provide from the GitHub, or you can do a simple copy and paste into the GUI of ESPHome if you want to make it easy. Now take note, you may see something a little bit different based on the actual file in GitHub, because we will be looking to tweak things as get more input and more usage. So definitely always check the GitHub for the latest YAML file. Of course, it's hard to paste off of a video anyway, right? So we'll copy all of that into the GUI. We'll go run down through a quick explanation, but you can go hit a lot of the different items straight out of the ESPHome documentation. As we showed in the ESPHome multi-sensor video, you can go and find all the examples and just simply copy and paste all your little pieces into the YAML file. Makes it super simple with ESPHome. And now with the updated version, it shows you if you do have an error in your code, you put in a little red X on the side, which is really beneficial when you're developing a new sensor. We'll go ahead and hit save just in case we don't click out of it. So for the substitution piece, it's basically going to save you from having to copy and paste your sensor name. I like to put the sensor name before the actual sensor title, like it'll be DigiWeather and then temperature, or I'll shorten it to temp. And that allows me to group things easily when I'm doing entity cards. You don't have to do it that way, but I just find it easy. and I can just change this at the top. And you'll see we do use the display name, and it's actually, I do call it display name. If you scroll down, look in the sensors, you'll see the $ display name. That's going to get replaced with what's at the top of DigiWeather whenever it sends that over to Home Assistant. I go ahead and leave all this the same. Of course, if you did want to do D1 Mini Pro, I didn't need that in my aspect of things because we didn't blow out the 1 megabyte that the D1 Mini has. Your Wi-Fi information, of course, will be possibly different. I am using static IPs here and not using DHCP because I have my ESPHome sensors on a different VLAN, and that allows me to easily flash them and use the ping side on the GUI. You'll notice I do use secrets for all this. That way I don't have to just go ahead and specify my IP gateway, subnet, DNS, etc. I also use the IP address in my secrets. Not that I'm trying to hide a local IP address, but it makes it easy to have all of my IPs, since I do use static IPs in ESPHome, in a one-stop shop, and that way I don't double assign an IP from another device to another without having to dig through all the various files. Just makes it easy for easy housekeeping. The API, a lot of people do use API with Home Assistant. It makes it easy to integrate things. I did have an issue with the API due to this device uses deep sleep, and it wasn't always connecting right, and I just didn't like it. And I do kind of prefer MQTT for things because a lot of times I use Node-RED for my various sensors. So jumping to the MQTT side, if you do decide to go MQTT, the one problem you'll get is the last will and testament. What the last will and testament does is it's a good option to use for sensors, but not this one. Last will and testament, if your device falls off the Wi-Fi, it will actually show unavailable in the GUI of Home Assistant, which that's a good thing. You can see that that light switch has a problem or whatever. Well, this device is going to fall off the Wi-Fi all the time because we're trying to do battery and save power. Well, you don't want that unavailable showing on that card when you're trying to see the temperature. So one little hack I found in the documentation was I found that if it said if you did the topic for the birth and the will differently, it would disable the last will and testament. So hey, let's give that a shot. It worked out. Maybe there's a little easier way. If you do find an easier way that is more foolproof, I would definitely leave it down in the comments down below. That'll be one of the tweaks we could change in the YAML file when we post it and update things on GitHub. We do want to allow OTA so we can send things over. Now, one thing we will mention about OTA, because we are using deep sleep. So if you have the device sleeping for, say, 5 minutes, and you only have a 30-second wake-up window, you'll need to hit that window perfectly if you're trying to send over a new bin file, because of course you can't OTA a device that's not on the network and sleeping. Now, of course you could pull the Wemos, hook up the USB, but that's a whole lot of work to get it out of your case and get it outside, etc. So we've covered I2C in videos below, especially with Tasmodo, and I'll leave the link up above and down below. I2C allows you to put a lot of various sensors just on 2 wires. Now, really there is 4 wires because you have ground and voltage, but the data wires, there's a data and a clock. That's the only ones you need for data. And you can actually daisy chain multiple sensors together as long as they have separate addresses. Think of them kind of more like Ethernet and IP addresses. You can have them all daisy chained together, but you do need different IP addresses per device. On this board, the data line is on GPIO 4 and clock is on GPIO 5. Now, by default, I am setting the scan to false. Now, what is the scan? If you do have a new device that we're not covering here and you don't know the address, well, you'll see on the documentation it says scan true. And what that will do, it allows you to hook up that I2C device and it'll scan the entire bus looking for all the addresses. And you can watch the logs in ESPHome and say, oh, there's my device, and that's the address, which we'll cover in a little bit later with the BME 280. But to save battery life and CPU time, once you're done with it and have it configured, turn off the scan. All right, so down to the money of the sensors. Of course, we are using the BME 280. So the BME 280, it uses temperature, pressure, and humidity. but it does work off of I2C. And you do have a lot of different options, which I do like for ESPHome. You can actually dig into the configuration of all your sensors, which is great for using ESPHome for. Now we've chosen to use the oversampling of 4x. Now you do have a lot of different options you can use for the oversampling. I didn't think we needed 16x, but of course you can change it to whatever you like and what you're comfortable with and what works for your sensors. Now the address that I had to use for the one I have, now it could change versus what chips you get or whatever. There is the address of 0x77. Now if you remember back, we talked about the I2C scan. If your device isn't coming up, go turn that scan on to true, watch the logs as it boots. It's going to show you the addresses it found. If you do see one that's 77, go ahead and change mine from 76 to 77. So this one does the humidity, pressure, and temperature. It is a very accurate device that I found, but I did find with the BME280 it is a very sensitive device, so that comes with accuracy, but it should work out great for this device. So this sensor does not come with the PCBWay kit, and you can also use whatever other Lux sensor you want, but I had this sitting around in my drawer. It's the BH1750 Lux sensor, and it should shine through the various light holes, and just being a white case, I should be able to get enough light showing on this sensor. Now, how do you wire it? Well, it's stupid simple. If you look here, there is the VCC, ground, SCL, and SDA. That's the clock and the data lines. So it's really simple. If you just match them up on the sensor itself, you can see on this one you have ground, SDA, SCL, and VCC. The ADD pin is going to be, if you want to pull that low, it will change the address, which that all ties in to, remember we talked about the addresses on I2C. You can't have two devices on the same address, but we didn't need to pull that low to change the address on this one. Now you do see there's other headers to add additional other sensors, and at this time we're just not using those, but as things progress we may add other additional sensors to this board. Now last but not least is the ADC platform. That's the analog to digital converter. It actually is feeding the battery voltage through a series of voltage dividers into the analog 0 pin of the ESP8266. Now typically the ESP8266 only allows a 0 to 1 volt. Well, on most breakout boards there is a series of voltage dividers that will allow you to feed 0 to 3.3 in. Well, we're higher than 3.3 volts, so there's another resistor on here that does a voltage divider, but then we have to allow for that and use a multiplier to bring that voltage up. Now, you may want to calibrate this little number here by testing your voltage of your battery. If it is off a little bit, just go ahead and adjust it. But it's a very important sensor. It allows you to see that battery, and you know if you're going to have to adjust the sleep. If you're using too much battery based on the solar amount of light in your area, definitely don't allow it to report as often. You may have to change it back to, say, 10 minutes every time it wakes up, and that will allow you to save on battery usage during the day. And since we already kind of touched on that, very simple, deep sleep. Here's the run duration. That should be enough time to allow the device to pick up Wi-Fi, drop a couple sensor readings, and even allow you, if needed, to also send over an OTA update. It allows for that larger window to push over. Now I'm using a 2-minute during this testing, but I may scale that back based on what I see with my battery usage. It will end up with, say, a 5-minute usage. I don't need the temperature every 2 minutes, and same thing for the light. 5 minutes will probably be fine, and we'll see how that does with battery usage. But of course, during the winter, I may even have to scale that back even more because I don't want the device to die during the night because there's not a whole lot of sunlight at times. So we'll go ahead and hit save. Now, if you do have it connected up to the HAS-IO device and you did pick your port, you could just connect the Wemos D1 Mini and hit upload. But we're going to use the ESPHome flasher. So at this point, we're removing the Wemos D1 Mini from the board and we'll flash it directly using USB. So we'll hit close, and just to make sure, we'll hit validate. We're good. Hit close, and at this time we will hit compile. So let it pull all the libraries and go ahead and compile. It should go through, and it may take some time depending on what you're compiling on. So while it compiles, let's go ahead and download the ESPHome flasher. We will leave the link down below so you can easily go pull this down. So just go to the GitHub page and go to releases and download the Windows 64 version. So once it compiled, you should get this successful, and we will download the binary down to our computer. So we are flashing this off the board. I didn't want to dual power things or mess with anything. Once we do get it flashed, we will put the board on the sensor and let it pull up off of battery. So we'll pick our COM port, and then we'll go pick our bin file that we just downloaded, and then we'll hit flash ESP. Go ahead and let it run and flash the ESP. Now you will see it reboot, and then it will show the logs, which will help you out if there's any errors like connecting to your Wi-Fi, etc. You will need to correct those, of course, before you do put them on the solar Wi-Fi board. Now, you will get the errors that it can't find the I2C, it can't find the BME280, etc. We know that's going to happen because we don't have it on the board. But just make sure it gets on your Wi-Fi. So it did boot up. We'll go ahead and unplug it. Let's put it on the board. So one thing to note when you go to plug in the boards on here, make sure you do verify the pins, that you don't plug it in upside down. For instance, the one way I'm holding it, you can see the TX and RX on the top right, and that's definitely not it. 3.3 volts and D8's the top right. So just follow the designations on the board and follow the pictures, and you will get everything right. Make sure you do not offset it by 1 or 2 pins. Of course, that might cause you a lot of issues as well. So real simple, just plugs in and verify that it is showing that the pins are all the way in and not offset. Now we're not doing the mod just yet on the external Wi-Fi antenna. I like to make sure we get everything working before we add something else into the mix. So we do have the battery on it, and do make sure you do have the jumper on it. The jumper is required for the deep sleep mode. Go ahead and make sure and turn the switch to on. Once you turn the switch to on, let's flip over to the dashboard and see if it comes up by hitting the show logs. So we already see it's online. It's probably going into a deep sleep, but we'll wait around and we'll see if it comes back up. So there we see it boot up. Go ahead and scroll back for errors and see if it communicated with the BME280. So of course, at this time, if you just sat there and watched the logs, you would see it come back up out of deep sleep and reboot and hit the sensors again and report all the necessary changes. So definitely working as planned. Good deal, and we can move on and move forward. Now, since we are getting sensor values, you can go ahead and add them to an entity card in Home Assistant or whatever home automation software that you may be using via, say, MQTT. So we can see we have the temperature reported 53 seconds ago, as well as the humidity, etc. in our cards. Good deal. We added that in. You can name them what you want and do what you want with them, or make gauges, etc. with Lovelace, whatever you feel you want to use for your weather sensors. And now, since we have everything working as planned, let's go ahead and throw it in the case and get things going and bring it outside. So all in all, pretty cool project. I'm more of a wired type guy. And even though with this, I was very impressed using the solar powered system. That way I could just put it wherever I wanted to in whatever part of the yard. Say if it's getting too much sunlight, causing the temperature to rise a little bit, maybe I can put it a little bit in the shade, even though I will get some solar to charge the battery during the day. The really cool part is no third-party service to rely on that would change APIs or I don't know. I wonder who would do that on us and not give us data anymore. I don't know who that might be with, say. So I appreciate PCBWay for the kit and helping make this project video. And big thanks to all the Patreon subscribers. You definitely help make future projects like this possible. If you're not a subscriber, hit that subscribe button. Give us a like, give us a dislike, and definitely give us a comment down below if you've built something else or some other weather sensor. I'd like to see all the various ideas and maybe we can incorporate something into another one. And y'all take care.